सो बेसिकली हमारा इस प्रैक्टिकल में पर्पस ये है दैट वी शुड अंडरस्टैंड कि ये जो इवेपोरेटर टेम्परेचर वेरी कर रहा है इन केस ऑफ ए जियोट्रॉपिक मिक्सचर, ठीक है, वी नीड टू नो कि उसको उसकी कैलकुलेशन हम कैसे करेंगे, कैसे इंश्योर करेंगे कि टेम्परेचर जो है 7 डिग्री सेल्सियस ही रहे, जैसा कि एक प्योर रेफ्रिजरेंट के केस में होता है। या कंडेंसर टेम्परेचर जो है 40 डिग्री सेल्सियस है, तो हम कैसे इंश्योर करेंगे कि ये टेम्परेचर जो है 40 डिग्री सेल्सियस रहे, क्योंकि यहाँ पे जियोट्रॉपिक मिक्सचर के केस में ये जो टेम्परेचर ग्लाइड आ रहा है, टेम्परेचर ग्लाइड कुड बी एज हाई एज 7 डिग्री सेल्सियस, okay, maybe 4 डिग्री सेल्सियस, 5 डिग्री सेल्सियस, depends upon the refrigerant or the rather blend of the refrigerant. Okay, so I am going to explain this fact using EES. So let us try to understand it. So first of all, I am going to options window, then I open the function information, I choose the fluid properties, and then let us consider a particular pressure. Okay, I want to calculate the pressure and the independent property is temperature. Okay, so I choose refrigerant, say R 407C. If it is available, I think it should be available. Most of the refrigerant nowadays which are coming are, yes, most of the refrigerants which are coming today are zeotropic refrigerants mostly. So this is the, I am changing it to 1. Paste it here. So this is T1. I take a particular value of T1. Okay. So let us say I choose it as 40 degrees Celsius. Let me see what happens. Oh, now what does it says? Just see it here. It says the saturation vapor pressure depends on both the temperature and quality for a blend. Use the pressure function to obtain the saturation vapor pressure. You know, in case of a pure fluid, there is no problem actually. You just, for example, if I change it to say R22, okay, and then I will check it, you can easily get the value of the saturation pressure. But now there is a problem in case of a mixture. So how to go about calculating these properties for a mixture? Okay, so the other way around is I will choose a particular pressure rather. Okay, so they have given a hint that we should go for some other function. For example, function information, once again I am going, so there will be, yes, now I will go for pressure. Okay, I have chosen same, and they are saying that you choose quality. Okay, so let us say once again it is 1 only, and paste it, and then I take the value of x1 is equal to 1. Okay, and calculate this value. Now let us see what does it says. The value of pressure comes out to be 1519. Okay, so this is the value of the pressure. Now what is this pressure? This is the pressure of the saturated vapor corresponding to 40 degrees Celsius. Now I will perform another, I will use this equation once again, but now I am going to change its name. I am saying that it is P2. Temperature remains the same, but and but I am going to change it to x2 now. Okay, and the value of x2, let us say I take as 0. Now you try to understand. I am keeping the same temperature, but now I am giving a different value of the dryness fraction. So let us see. Now you can see here. What do you find? There are two different pressures. if I am considering x1 or the dryness fraction as the value as having value 1, then the pressure comes out to be 1519. Whereas if I am using x is equal to 0, the pressure is 1737. So it is showing two pressures corresponding to the same temperature. And this is because it's a zeotropic mixture. Okay, it's a zeotropic mixture. So zeotropic mixture is having two different pressures corresponding to a particular temperature. Now let us change it. What I am going to do is, now I will choose a particular pressure. Let us say P1 is equal to, I guess, I say that 1600, because you have just seen this value. Means 1500, one value was near to 1500, other value was near to 1700. So I am choosing a similar value of 1600 kilopascal. Okay, what I will do now, I go here and go for the function information. Now I will be calculating the temperature. Okay, so I would like to calculate the temperature. So let us say I will give quality now. So first of all, let us okay, 1. So let us paste it. It should be here. Okay, and let us say the value of x1 is equal to 0. So calculate. What do you find? It is 36.66. Okay, and now what I will do, I will take this equation once again. I am changing this temperature to T2. I am changing this to x2, and let us say I put x2 equal to 0 and calculate. Now what is the value of okay, now you see the why is पहले भी क्या 0 लिया था. Okay, I have taken both the values as 0. That is the problem. So I will take it as 1. Okay, so once again I calculate it. Now you see it. Now what is the temperature? Now the temperature is 41.98. Okay, so there are two temperatures. Now the question arises, how to get the value of temperature in the condenser as 40 degrees Celsius. Now you have seen a particular procedure. I have done two types of the calculation. See, one thing you should always bear in your mind, that the pressure in the system will not change. For example, if it is the evaporator, the pressure will never change. We are considering, theoretically, we are considering that the pressure will remain constant in the evaporator, and the pressure will also remain constant in the condenser. Okay, we are neglecting pressure drops. For the theoretical calculation, you should consider the pressure to be constant. But we should also ensure that there is a particular value of the temperature in the evaporator. Now, what is happening? For the condenser here, you can see there are two temperatures, 36.66 and 41.98. 36.66 is corresponding to dryness fraction of 0, whereas 41.98 is corresponding to a dryness fraction of 1. Is it clear to you? So what is the average temperature here? Can you calculate it? Tell me. कैलकुलेट करो और बताओ.
सर 39.32.
39.32. So इसका मतलब that means it's very near to 40 degrees Celsius. So I am trying to calculate a pressure corresponding to which the average temperature in the condenser is 40 degrees Celsius, but it is not the exact value. So what I will do, let me change it to 1625, and now I will calculate. Now what are the values? Now you calculate what is the average temperature in the condenser. Tell me. I think
Sir, 39.925.
39.925. So I am near to 40 degrees Celsius. If I want to go exact, so what I can do is, now you just see it. I will tell you how to reach up to the condenser temperature, which is equal to T1 plus T2 divided by 2. Okay. So I will, what I will do, I will just comment this and then go here in the tables. I will make a new parametric table. I want to calculate the value of P1 corresponding to which the temperature is, average temperature is 40 degrees Celsius. So I will say, I will take TC here. Okay. And I can say I will take 100 values here. Okay. I know corresponding to 1625, it's very near. So let us take 1625. And the last value of the pressure which I am considering here is, let us say, it won't be, I don't need to take much. I can go for 1640 actually. Okay. So these are the values. You can see 16. Yes, you can see it here. I am changing this. Just a minute. What I will do, I will show you properties. So automatic format, I will say fixed decimal number of digits is say 2. Okay. So now you can see its variation is being shown here. Okay. So I will click here. Now you tell me where corresponding to which pressure the temperature is 40. So it's very clearly visible to you. What should be the pressure in the condenser for which the
It,
average temperature will be
sir,
40?
1628.0.
1628. Okay. So now you have understood that how you are going to maintain the temperature in the evaporator and condenser for a zeotropic mixture. Is it clear to you? So basically, suppose you have to, just a minute. So for example, you want a temperature of 40 degrees Celsius. So you have done change this pressure. So now you know that you should keep this value as, you can say this is PC, because you want 40 degrees Celsius and you change it to 1628. Now corresponding to this pressure, you will see that the average temperature comes out to be, okay, just a minute. What is the problem? Six
The
equation.
TC commented
Okay, because we have
TC.
not used TC actually, so we will change it here. PC. Okay. We'll change it to PC now. Okay. Now you see it. So TC comes out to be exact 40. I can see it may not be 40 also. I have to auto format. Let us go for fixed decimal 1 degree. So it is 40.0. Exact 40 you get. Okay. So that means if you want to keep a pressure, if you will keep a pressure of 1628, the condenser temperature will be 40. Now suppose what I will do, uh, now I want a temperature of say 7 degrees Celsius in the evaporator. So same procedure I have to do. Now let me copy all this and then what I will do, I will change it. So I say that this is PE. I choose arbitrarily as 1200. I don't know what value I am going to get. Okay. And here also I will change it to, and here also I say it is T3. Here it is PE. Here once again it is PE. Let us change it to T4 and change it to X1 also has to be changed. Let us say X3. So you could not, there was no need actually, because we know the values of X1 and X3 actually. Okay, वो same thing. Chalo, but to differentiate I have changed it X4. Okay, and here it is 3, here it is 4, and let us make it TE. Best way could be that I go for a table, but I am checking it now. Okay. Now, what is the value of TE? It is 28. So that means it is not the correct value. Okay. Let's go to say 900. Okay. Let's see, 18.25. So it's not the correct value. I want 7. Say 500. So what is the value of TE? Minus. So it has to be greater than 700. Okay, 500. So let us go for say 600. I'm just trying. So yeah, now you can see it. So it's very near to 600. Now what you can do is you can make once again a table. Okay, varying between say I can go first to back to I can comment it. Okay, go to the table, new parametric table. I need PE and I add this value, and then I need TE. Okay, so I say, let us say once again go for 100 values. अच्छा 5 आया था ना इसमें अभी, कि 7 आया था?
Sir, 5.
5, sir. 5.
5 आया था तो ठीक नहीं था. So what I will do, okay, doesn't matter. I can refine it always. 600, and here I will take suppose 700. So now I will get the value of T. मुझे 7 चाहिए. देखो आ रहा है कहीं पे 7. लो ये आ गया. So 639 के आसपास 7 आ रहा है ना. So what I will do, I will go to 639 से थोड़ा सा लोअर चले जाओ. 638 और 640 कर दो, अपने आप पता लग जाएगा. सो ये लो, ये मैंने इसको यहीं पे दोबारा चेंज किया, इसको कर दिया 638 और यहाँ पे मैंने कर दिया 640. लो इसको यहाँ पे रन करा. लो जी, now you are able to get, here you get the value as 7. लो perfect 7 you get here, 639.3 degree 3. So this should be the pressure. Six 39.3. Now you get it. Now you see it here. अब आ गया 639.3, and you get a evaporator temperature as 7 and condenser temperature of 40. So this is the approach to solve it. Means how you are going to keep the pressure as constant and average temperature as constant, 7 degree and 40 degree. See, otherwise क्या है, you can see it here. Otherwise तो यहाँ पे जो temperature हैं they are different actually. ये जो temperature है अगर आप TS diagram पे plot कर रहे हो, so the cycle is something like this. Okay, this is a cycle 1, 2, 3, 4. But now there is another thing. See, when you have to calculate the properties, you have to take the temperature at this particular point. You have to take the temperature at this particular point. Okay, though this average temperature here is 40, this average temperature here is 7 degrees Celsius, but when you are calculating the properties, see, there is some error in this analysis also, because what we are doing when we are calculating this 7, we are taking this particular value and this particular value. However, the entry to the evaporator is at this particular point, यहाँ पे है. लेकिन आप कौन कौन सी वैल्यू लेके एवरेज निकाल रहे हो, इसको और इसको लेके निकाल रहे हो. ये जो पॉइंट है इसको लेके नहीं निकाल रहे, जो कि एक्सपेंशन डिवाइस के बाद है. सो थोड़ा सा एरर यहाँ पे रहेगा जो हमने प्रेशर कैलकुलेशन करा है, बट दिस मच इज एक्सेप्टेबल. ओके, बट जब आप कैलकुलेशन करोगे तो कैलकुलेशन कैसे करना है, कैलकुलेशन आपने जो जहाँ पे टेम्परेचर लिया था और जो यहाँ पे टेम्परेचर लिया है उसके बेसिस पे H1 की वैल्यू कैलकुलेट करोगे और H3 की वैल्यू कैलकुलेट करोगे, और तब जो है COP कैलकुलेट करोगे. इज इट क्लियर?
सर X4 का अगर ड्राइनेस फ्रैक्शन निकाले 4 पॉइंट का तो फिर करेक्ट मिल जाएगा आंसर.
4 पे निकालना है ड्राइनेस फ्रैक्शन. ओके, देखो इसको ना थोड़ा सा सोचना, ठीक है। अब आपको एक मैंने एक तरीका बताया, अभी टाइम भी 11 पूरे बज गए हैं, आपकी दूसरी क्लास भी है, अभी मैं डिस्कस नहीं कर रहा, थोड़ा सा मुझे भी सोचना पड़ेगा। मैंने इसको काफ़ी अराउंड आज से इस प्रॉब्लम को क्रैक किया था कोई 15-16 साल पहले, जब मैं पीएचडी कर रहा था। ओके, आई डिड फॉर दिस पर्टिकुलर रेफ्रिजरेंट ओनली। अभी तो मैंने आप लोगों को ये एक्सप्लेन कर दिया हाउ टू कैलकुलेट दी ड्राइनेस फ्रैक्शन एट पॉइंट नंबर 4 बिकॉज द टेम्परेचर देयर इज अननोन। So that once again is a you can say you will have to do some hit and trial. ओके, हिट एंड
ओके
ट्रायल कैसे करना पड़ेगा, एक टेम्परेचर एज्यूम करना पड़ेगा। जैसे हम सपोज ये लाइन है ना, जैसे ये लाइन है, ये लाइन जो है, अब इसमें कंटिन्यूसली टेम्परेचर इंक्रीज कर रहा है। सो यू हैव टू एज्यूम ए पर्टिकुलर वैल्यू ऑफ द टेम्परेचर हेयर, then you know the enthalpy here, then you will calculate the value of x, okay, and then means corresponding to pressure and the value of p and x, you once again calculate the value of enthalpy. If both the enthalpies match, then the value of the temperature which we have considered here is correct. तो
यस
थोड़ा सा
सर।
मतलब सोच के करना पड़ेगा, इतना इजी नहीं है, मतलब हिट एंड ट्रायल यहाँ पे भी घुमाना पड़ेगा। इज इट क्लियर?
यस सर यस।
हाँ, तो थोड़ा सा पहले अभी अभी तो क्या करो आप इसको जो पॉइंट नंबर 4 को ड्राइनेस फ्रैक्शन भूल जाओ, ड्राइनेस फ्रैक्शन की जरूरत नहीं है, क्योंकि आपके पास अगर पॉइंट 1 पे एंथैल्पी आ गई तो 2 पे ऑटोमेटिकली मिल जाएगी और 3 पे भी मिल जाएगी, और 4 जो है दैट इज इक्वल टू H3। तो सीओपी कैलकुलेट करना है। अब आपने आज की जो प्रैक्टिकल प्रॉब्लम है, आपने R410 के लिए और 407C के लिए, दोनों के लिए जो है 410A और 407C के लिए, दोनों के लिए आपने सीओपी कैलकुलेट करना है। इसी ईएस पे प्रोग्रामिंग करनी है उसकी। ओके, और मेथड मैंने आपको पहले बता दिया। और इसमें जो आपने टेम्परेचर्स लेने हैं, टेम्परेचर आप ले लो एक 45 डिग्री सेल्सियस और दूसरा ले लो 0 डिग्री सेल्सियस। कंडेंसर टेम्परेचर 45 और इवेपोरेटर टेम्परेचर 0 डिग्री सेल्सियस, एंड यू कैलकुलेट ऑल द एंथैल्पीज एंड द सीओपीज फॉर बोथ द रेफ्रिजरेंट्स and then compare them, and then you can vary it also corresponding to condenser temperature. Now सोचो कि अगर तुम्हें कंडेंसर टेम्परेचर को वेरी करना पड़ जाए तो प्रेशर कितनी बार कैलकुलेट करना पड़ेगा। ओके, आई वांट दिस वेरिएशन फॉर कंडेंसर टेम्परेचर ऑफ 45, कंडेंसर टेम्परेचर ऑफ 50, 55, 40 and 35, and let us keep the evaporator temperature as 0 degree Celsius. Or alternatively you can also try for a constant condenser temperature, say 45 degree Celsius, and you calculate you draw the graph for T which is varying between, let us say, -10 to +10। मतलब यहाँ पे आपके पास 5 वैल्यूज आ जाएंगी, -10, -5, 0, 5 एंड 10। ओके, तो 5 वैल्यूज में आपका ग्राफ अच्छा मिल जाएगा आपको, टी के साथ वेरिएशन सीओपी का कैसे होता है, यहाँ टीईसी के साथ वेरिएशन कैसा होता है। दिस इज व्हाट यू हैव टू डू। दिस इज द प्रैक्टिकल प्रॉब्लम फॉर टुडेज क्लास। एनी क्वेश्चंस? टेल मी। तो इस वीडियो को मैं अपलोड कर दूंगा मैं